Page 446, number 45. Find the projection of u onto v. Then write u as the sum of two orthogonal vectors, one of which is the projection of u onto v. And we're given vector u and vector v. Okay, let's start with a formula. And this formula is for the projection of u onto v. And to find that, what we have to do is first of all find u dot v over the magnitude of v squared, and then multiply that by vector v. So we're going to get some numerical quantity here. We'll multiply that by vector v. Okay, so first of all, u dot v. To find the dot product, we can multiply the first coordinates. 3 times 8 is 24. Plus multiply the second coordinates. 4 times 2 is 8. So we end up with 32. Over the magnitude of v squared. Well, v is a vector that goes 8 units right and 2 units up. So vector v looks something like this. To find that magnitude, we can use the Pythagorean theorem. 8 squared is 64. 2 squared is 4. So the magnitude would be the square root of 68. Now I'm finding the square root of 68 squared. The square roots will just cancel out, and we'll just be left with 68 times vector v, which is 8, comma 2. Okay, so 32 over 68. Can we reduce that at all? Sure we can. That will reduce to 16/34, which will also reduce to 8/17. So I have 8/17 times 8, comma 2. Now if I multiply 8/17 by each of these quantities, I will end up with 64/17, comma 16/17. So that vector right there is the projection of u onto v. Now sometimes we label that vector w1. Okay, that's the first part of this problem. Find the projection of u onto v. Second part, write u as the sum of two orthogonal vectors, one of which is the projection of u onto v. So basically what we want to end up with is, I'll put it down here, w1 plus w2 is equal to u. Well, I know vector u. I know vector w1, I just need to find vector w2. And if I subtract w1 from both sides, I have this formula. To find w2, I take u minus w1. Okay, so I know vector u is 3, comma 4. I need to subtract w1, which is 64/17, comma 16/17. Okay, to do this subtraction, we need a common denominator, which is 17. So I can write this as 51/17, comma 68/17. There's vector u minus w1, which is 64/17 and 16/17. So in the end, w2 is equal to, if I subtract those, 51 minus 64 is negative 13/17, comma 68 minus 16 is 52/17. And there's vector w2. So in the end, to write this as a sum of those orthogonal vectors, I need to say u is equal to 64/17, comma 16/17, there's w1, plus w2, which is negative 13/17, comma 52/17. And there's my answer, the projection of u onto v plus vector w2.